So I just wanted to point something out. If I've got just a general discrete random variable, so we go down here to 14, we worked through a very similar problem in class. So, the values are the same, but, I could change them around a little bit. But anytime you have different outcomes and the probabilities associated with seeing those different outcomes, you should be thinking you've got this kind of discrete random variable, right? It's something that hasn't happened yet, but the probability of seeing different values for this variable x. So you could find the mean or the expected value, and you could also do the variance or a standard deviation for that discrete random variable as well. So we'll walk through these examples and I'll point some things out. So in A, I said, what's the mean bonus amount? So if I go to my formula sheet, where's it at? Here it is. Here's the mean and the variance equations for my discrete random variables. So all I'm going to go through and do to find that mean or the expected value is take every outcome x and multiply it by its associated probability. Right? So if I look at practice exam A, practice exam B, I'm just going to go through, take every x value, so 10 times 0.15, and multiply it by its associated probability. Next outcome of 6 times the probability I see 6 occur. Next outcome of 3 times the probability I see 3 occur. Next outcome of 0 times the probability I see 0 occur. Right? I think this should work out to, you get a mean of 4.2. Right? So this is should be how you find the mean of a discrete random variable. Okay? Now, first of all, are there any questions on that? Like I said, we worked through a very similar problem in class, but the next part is what is a little bit different. So because this is kind of multiples, I don't want there to be cascading errors, right? So if you got the mean wrong, when you go to calculate the variance or standard deviation, well, you're looking at the deviation from the mean, so you're automatically going to get that one wrong as well. Yeah.
So did you divide like 5.15, or did you multiply it?
Yeah, these are all, multiplication. Yep. They're kind of faint and small. So yeah, I went through, took every x value, and actually these aren't weights. These are technically, right, we're using the probabilities as weights. Yep. Any other questions before we keep moving? So if you got the mean wrong, when you go to calculate the variance, you're inherently going to get that wrong as well, right? So what I'll do on these, anytime there's information that you would kind of need from the previous problem, I'll give you an assumed true value. Now, don't read into these values at all. This one happens to be pretty close to what the real answer was. Sometimes I will give you things that aren't close to the real answer for a very specific reason, right? So don't read into these assumed true values at all, but let's just assume that the mean was 5 million. Right? And sometimes I'll give you assumed means, also makes the math a little bit easier. Right? I give you a nice integer here. So I've got the mean of 5 million. That's what I should be using to calculate my standard deviation. Now, if I look at my formula sheet, I only have the equation for the variance, but once I find the variance, what's the only other thing I need to do to get the standard deviation? Simply take the square root, right? So I'll find that variance first, then take the square root to get my standard deviation. Okay? So this equation tells me just go through every possible outcome for x, find the deviation from the mean squared, and then multiply that by the associated probability of seeing that specific value for x. So I'll go through the very first value, which is 10, subtract that mean I was given, which was 5 million, square that value, and then what's the probability I see 10 occur, or that I see this deviation from the mean? Well, that's 0.15. I then go to my next outcome, which was 6, subtract that mean, square it, multiply it by the probability I see 6 be the outcome. And from there, I've got what? 3 minus the mean squared times the probability I see 3, plus the last outcome of 0 minus that mean squared times the probability I see 0. Okay. So I just went through every single possible outcome, subtracted the mean, squared that deviation, and then multiplied it by essentially the probability that I see that deviation from the mean, right? Or that I see that outcome for x. I don't know. I have to actually put this into a calculator. But if I'm looking at this, first of all, which of these answers can I rule out right away for 15? One of these things is not like the other, right? I can rule out the negative value. Why? But because variances and standard deviations, the lowest they can ever be is 0. I can't see a negative value. There's just, at the worst, there's no variation, right? 0 variation. So I know that I can't have a negative value for my variance or standard deviation. I don't know what this ends up being. My guess would be 3.25. So I'm guessing if I calculate this, it's probably 10.6. I then still have to, right, this represented my variance. So my standard deviation would be the square root of that. Let's see if I'm right. I don't know if I have the answer key pulled up now. So I did have it. So we were on what? 15 and 16. So D and A. So 6. Oh, so yep. So D, right? If I end up kind of calculating this out, it does end up being about 3.25. Okay. Any questions on that one? If I ask you something like this, it should be one of the easier problems on the exam, as long as you kind of pay attention to the equalities here. Okay. So let's say I gave you something like this and I said, what's the probability that you see a bonus amount be at least 3 million, or that X is 3 million or higher? Right? Well, if I want the probability that it's 3 million or higher, probably it's 3 million plus the probability it's 6 million plus the probability it's 10 million. Those should just add up to 0.8, right? So all you're really doing there, I don't overcomplicate it. You just want the probability that it's greater than 3. Well, I either see it be 3 million, or I see it be 6 million, or I see it be 10. And because this is a discrete random variable, like I'm going to only see one of those outcomes. So they're all mutually exclusive. There's no overlap, right? So I either see exactly a $3 million bonus, or a 6 million, or a 10. So I can just add those probabilities up. There's no intersection to subtract, right? And so yeah, so it's kind of like, this is almost like the idea of finding kind of like a cumulative probability, but we're not working down, we're working kind of from a certain value and going up to the highest amount. Now, what if I had asked for what's the probability that it's greater than 3 million? Well, that's where you got to be careful with the equalities, right? If it's just greater than 3 million, what's the first possible outcome that would meet that criteria? Well, the first thing that's greater than 3 million would actually be the 6 million, right? So then I would just add up the probability of 0.25 and 0.15 and be, only 0.4. Okay, so really that should be a pretty easy problem as long as you're paying attention to that equality.